Hey, what's up everybody? Mark Price here at Devslopes.com, and today we are going to continue our discussion on programming, and you are going to learn how to work with numbers. And so you can pull open your previous code here, which is variables.cs, and we've talked about strings already. Let's talk about numbers. What is a number in regards to programming? Well, it is simply a number you can work with, okay? No different than you might work with on a piece of paper. And to show you, a very good example would be HP for hit points, right? Usually start off with like 100, maybe 100 hit points, okay? So we say int HP 100. So int is short for integer, okay? And an integer does not have floating point numbers, no decimals, okay? So you would not use an integer for money or currency or anything like that. But it's great for hit points because hit points are usually whole numbers, okay? So int HP equals 100. Well, what else do we have? Well, maybe we've got shield power. Yeah, 76.5%. Okay, so our hit points are 100, but our shield power, now that's like a percentage, right? So we're going to say 76.5%, and we are specifying here the keyword float. If I take away float and put integer, okay, it's going to have some issues, all right? It's not going to work, and you're probably not going to see it here. It's probably going to be over here in our terminal here. Yep, as you can see right there in Unity, it cannot be converted to an int. Of course it can't, because it is a float. It has a decimal. So we'll undo that here. Okay, so integer, float. And what can you do with numbers? Well, right here we're assigning values. Notice how the values of these numbers do not have quotes around them like a string does, okay? Strings have quotes around them. Numbers do not have quotes around them. Very, very important difference, okay? So let's just do a simple math operation. So let's say HP minus equals, okay, so minus equals, okay, this is a binary operation. That's going to take the existing result of HP, so it's going to take 100, and it's going to subtract whatever we're about to do from it and put it back in. Okay, so what we're going to do is we're going to say HP equals, what do we want it to be? Well, let's say a laser is coming in to attack us. So let's go up here, and we're going to call this laser damage equals, let's say 15. It's going to do 15 damage, right? But we have shields, okay? Shields are going to deflect a portion of that damage because that's what they do. And so HP, you know what I always wonder? It's like on Star Trek, okay, or even Star Wars, like the enemy's right there, and they're about to get into battle, and then they start getting hit by the lasers, and they're like, shields, power, full up, put them up, hurry, you know? And it's like, why didn't you do that in the first place? I mean, it was a switch, right? Okay, and maybe you can fix that problem in your game. All right, so we're gonna say hit points equals hit points minus, that's what we're saying, hit points equals hit points minus, and we're gonna say shield power. Okay, so what do we want to do? Shield power, no, we do want it to be laser damage, but laser damage needs to be reduced actually. So what we're gonna do, let's do some order of operations here. We're gonna say laser damage, okay, and let's say laser damage minus, say laser damage time, or shield power, excuse me, is gonna, we need to subtract from the laser damage. So HP minus laser damage, what do you want to say, 10% maybe? Like, so 10% of the, let's say 5% of the shield power, or just 5% of the power should be reduced from laser damage since we have our shields up. That's what I'm trying to say. Laser damage, so this time we're going to do multiplication times 0.05. Okay, this is interesting. Okay, so what we're saying here is health points or hit points equals hit points minus laser damage times 0.05. Well, let's take a look at that here. So I did command space on the Mac here. We're going to say, this is just a calculator operation. So we're going to say 15 times 0.05. Okay, so it's going to take off 0.05 hit points. Let's make this number a little bit bigger. Let's say 30. There we go. Let's make our laser damage hit points 30. So we can expect to lose 1.5 from the hit points, okay? So HP equals HP minus laser damage times 0.05. Okay, so cool. Looks good to me. Let's go ahead and see if it worked. We're just going to print out the HP. So we're going to say HP. We're going to add. This is called string concatenation. Okay, we're gonna add the HP variable to it. Okay, so it's going to take this value of this hit points, this integer here, and it's going to convert it to a string and add it onto here so we can actually read it on the console. Let's see what happens when we run this. Okay, cannot convert type double to an int. Okay, so we have some problems here we have to solve, right? So why is it saying double? Well, a double is another floating point number. It's longer than a float. Okay, so double. And this one is, we're going to call this actual damage percent equals 0.05. Okay, and then we can actually use that here instead of hard coding the value in. So it actually helped us write better code. And you can't just interchange types. Okay, it doesn't work like that. So now what we're saying here is it's a lot more readable. We're saying the hit points equals hit points minus laser damage times actual damage percent. Okay, and so it's going to multiply this and then give us our actual damage here in the HP. So let's save this here and then run it and see what happens. Okay, and then there's one more problem. Okay, it can't convert this operation right here. It cannot convert it into an integer to work with this HP right here. Okay, so we actually need to convert all of this to an integer. You're starting to learn how to work with numbers that they're different. The types are different. You can't just cross an integer with a double. You got to do some work for that. Convert this to an int. Well, it should be as easy. All right, what we'll do is we'll separate this on a different line here. We're going to say int actual damage equals, okay, and then what we're going to do here is just cut this, paste this here, okay, and then what we'll do is we'll say int. I think this is more readable, so oops, and put our semicolon here. There we go. Okay, now we're starting to really build a game here working with numbers. Okay, you've worked with some ints, some floats, and some doubles. So let's recap from the top. Our hit points are 100. It's of type integer. Okay, it's a whole number, no decimals. Our shield power is of type float. Okay, 76.5. And our laser damage is also an integer, but our actual damage percent is a double. And what's interesting here is, even though this has a decimal and this has a decimal, we're calling it a double. Did we have to? No. This could have been a float as well. But this is just to show you that you can choose to use double. Now keep in mind that double is for double the digits, okay? So if you need really, really long digits, okay, then double is what you're going to want to use. And you can look up the actual definitions of how many digits a double versus a float can have on the internet. Just do a quick search, C#, what is the capacity of a double, and it will tell you, okay? And so what we're saying is the actual damage is going to be laser damage 30 times actual damage percent, okay? And this is going to be 0.05, and it's going to stick it in there. And then we're going to say hit points is now equal to hit points minus actual damage. This also could have been written out. I'm going to make a comment here, which is code that is not read by the compiler. I'm going to say hit points equals hit points minus actual damage. So this is the exact same thing as this. It's just shorthand, okay? So hit points equals hit points minus actual damage. So 100 minus actual damage. Let's save it here, and let's go run it here in our application. Oh, one more cast it wants us to do. If you notice that, what it says here, literal of type double cannot be implicitly converted to a type float. Add suffix f to create this literal of this type. Okay, so what it's saying here is it cannot multiply. Actually, I think it just wants the F there. That's what I think it's saying. There it is. Okay, so all the errors are gone, and what we did here is on the double, it's asking us to put an F there to specify that it's a double, and that's how you can in your code specify if it's a double versus a float. Float here. So anytime you want to use a float literal, you put the F at the end of it, and then the double does not have that. And now if you look at your code here, even without looking at the float and double, you can tell which one is definitely a float and which one is definitely a double. And so let's go ahead and run this program and see what our new HP is. HP is now 99. Okay. You're probably wondering, wait, why is it 99? It was supposed to do like 1.5 damage, right? Well, let's take a look at the math. So 30 times 0.05 is 1.5. Why is it only dropping it by 1? Well, the moment that we do this right here, okay, the moment that we cast it to an int, it drops the decimal point, okay? And so it only did 1 damage. So that's something very important to understand in your games, okay? You can't just cast back and forth and expect it to work. So it's going to drop off the decimal. Well, 1.5 is a lot. That's halfway to 2. Okay, so that's not really fair or accurate. So maybe it would have made more sense to round it up, or to maybe not use an integer here for the HP, but to use a float. So that could be something you might want to do as well too. Just know that you lose that precision the minute you cast it to an int. You lose the decimal places. Okay. I know it's a lot to take in, but when you look at what's really going on here, you're creating an integer, which is a whole number. Okay. Well, it's a number without a decimal, excuse me, okay, because you can use negative numbers here, like so, okay? And then we've got a float, which has a decimal that you specify at the end of the float literal with an F, okay? Another integer, all right? And then we've got a double, which is longer than a float, if you want to use it. We didn't have to, but I just have it here in our case, and it says 0.05. And then we're taking this integer, actual damage, we're creating a new variable called actual damage. Okay, and then we take the laser damage, which is an integer, and the actual damage percent, which is a double. We multiply those and then cast it to an int. And this is where we lose our decimal place. That 0.5 is gone now because we just turned it into an int, no decimals. And then we say hit points equals hit points minus actual damage. So we take the existing hit points, subtract the actual damage for it, and shove it back into hit points. There's probably only one more thing we need to do to actually make this more like a realistic game. Anytime your shields get hit, they should always decrease, right? So maybe it's our shields that are decreased by the full. Let's see. Actually, it wouldn't be the full damage. It would be the actual damage. It would be the laser damage minus the actual damage. So what we'll do is we'll take 30 minus the 1, and then that's what we subtract from the shields. That makes a little more sense. You know, the shield takes some damage, so does the user or the player or the ship or whatever. So then we're going to say the shield power, we'll do it the longhand this time, equals let's say it was laser damage. Okay, so equals laser damage minus actual damage. Okay, so shield power equals shield power minus laser damage minus actual damage is what it should be. Okay, so we're going to put one more thing here. We're going to say shield power. All right, so minus. So shield power equals shield power minus laser damage minus actual damage. So we're going to take this laser damage, and then we actually subtract the actual damage from it. So that's like 1.5 or 1 in this case because we lose the decimal. Brings us down to 14. And so shield power is shield power minus 14. And so we should see shield power, well, let's do some math. 76.5 minus 14. It should be about 62.5, I'm guessing. Debug.log. And we're going to say shield power. And this is going to be shield power. Let's see what happens. If I run it, shield power is 47.5. My math was definitely off. Let's take a look at it. One of the important things that you're going to do when you're learning to code is you're going to be doing a lot of debugging, and it is so important to make sure that your numbers are matching up. That's why we run tests and do calculations. Why is shield power 47.5? Let's go look at our code to see why. So up here, shield power is 76.5. Okay, that makes sense. Laser damage is 30. So what we're saying is 30 minus an actual damage should have been 1.5. So 30 minus 1.5, but it's actually just 1. So that brings us to 29. So my math was wrong. I just told you wrong. So this brings it to 29. So this would be 76.5 minus 29. 47.5. That's looking a lot better. Yep. So the math that I was doing a lot in my head on the calculator was incorrect. Okay. So 29. Yep. So our shields are down. Looks good. Yeah. Cool. So we've worked with ints, we've worked with floats and doubles. We've done some multiplication, we've done some subtraction and addition. You can also do division. Okay. I'll just show you some simple math here. So we can say int, let's say pi equals, 10, or let's call this slices. So equals, let's say there's, well, it doesn't matter. This is just division. So if you want to divide 10 divided by 5, for instance, to get slices, whatever that may be for your particular game, what do you think it's going to be? It's going to be 2, of course. So this is the division symbol right here. Okay, it's this this /, and it's going to store the result in there. Okay. So let's go ahead and print this here. Another thing we could do is we could actually just print these as well. So we could say slices. Slices. So we should see that printing 2 to the console. Okay. 2. And sure enough, it does. So that's working. Now, what if we do something like this? What if we said int, and let's call this new damage. This is just some arbitrary name, okay? And we said new damage equals 10 divided by 3, okay? What would you expect this to print? Let's take a look. 3. Why is it not giving us a remainder? Okay. And the reason is the division operator does not give you a remainder. If you wanted the remainder, you have to use a different operator, okay? And it's called the modulo operator. So we'd say int new damage remainder equals, and then we could say 10, and then you use the %, and 3, okay? And now what we can do is we can say, we could do a long one. We could say 10 divided by 3. Okay, so 10 divided by 3 equals, and then we can do a +, and we'll say new damage. Okay, and then we say plus. Let's put a decimal there in a string format. We're going to create the decimal, and then we'll say plus new damage remainder. Okay, so you have to do the 2 operations to get the remainder if you want it to display it like this. And so what we can do is we can now run it. Okay, 10 divided by 3 equals 3.1. Okay, maybe point is probably not what I should have done. I probably should have just said with a remainder. With a remainder of 1. Okay, so we're just doing some simple high school math here. Okay, so we've done division, multiplication, subtraction, addition. Really cool stuff. C# does have some other math operations where you can get like pi, or you can floor things, which means bring them down to the lower number, the lower whole number, or ceiling to the highest number. And then Unity has its own functions as well to do those things too. You have a whole arsenal of mathematical tools at your hands, but this is the basics. And most of what you'll be doing will be using these type of operations in your code. Really, your opportunities are limitless with using strings and numbers like we've done so here. So we're gonna call this video done. It's a lot to take in, but you'll be using this over and over again, so you'll really start to get a feel of how to use it in a real game. So that's it for now. Mark Price at devslopes.com. Moving on and forward.